Let's go ahead with the next set of formulae. Now these are some expansion formulae that we have done in one of the earlier videos. What I want you to do is, in this set of formulae, try adding up the first and the second formula with each other. So when you are adding up the first and second formula, you get on the left sine a plus b plus sine of a minus b. But on the right hand side, when you add this term plus this term, that will give you 2 sine a cos b, but this minus this is going to get cancelled. So what we just saw is, when we are adding up the two formulae here, then on the left hand side what we get is sine a plus b plus sine a minus b. The expansion for this sine a cos b plus cos a sin b. The expansion for this sine a cos b minus cos a sin b. So when you add up the two of them, the first term was getting added. So we were getting 2 sine a cos b. The second term was getting subtracted. So this was the final formula that we were left with. And that is an important formula that you should know, that sine of a plus b plus sine of a minus b gives you 2 sine a cos b. It's not in this manner that the formula will be applied. The formula while application will be applied in the reverse way. So 2 sine a cos b is what we will be writing as sine a plus b plus sine a minus b. But at the time of writing the expansions or using this formula, it's necessary to know this forward simplification, and only when you know the forward simplification, you will be able to apply the formula in the reverse sense. Try going ahead with one more simplification. Instead of adding the two formulae, why don't you subtract them? When you subtract them, on the left hand side it will be sine a plus b minus sine a minus b. So you have sine a plus b minus sine a minus b. These two terms get subtracted. Cos a sin b minus of minus cos a sin b, that gives you 2 cos a sin b, and that's the value for the second formula. Value in the sense, that's the expansion, or that's the final simplification of this entire expression. So you have 2 cos a sin b as the final simplification of sine a plus b minus sine a minus b. You need to do exactly the same thing with the last two formulae. That is, initially add up the two formulae. If you add them up, you have cos a plus b plus cos a minus b. That should be equal to these two terms getting added. But these two terms, when you add them, they are going to get cancelled. So we will have cos of a plus b plus cos of a minus b. Cos of a plus b, cos a cos b plus sin a sin b. To it you are adding, cos of a plus b, cos a cos b minus sin a sin b. To it you are adding cos a cos b plus sin a sin b. So the sin a sin b terms get cancelled and you are left with 2 cos a cos b. And finally the last one, try going for cos of a plus b minus cos of a minus b. Now you will face a little bit of trouble here, because cos of a plus b, this was cos a cos b minus sin a sin b minus cos of a minus b, that will be cos a cos b plus sin a sin b. Open up the bracket, this becomes minus here, this becomes minus here. So cos a cos b minus cos a cos b get cancelled, and these two terms getting clubbed with each other, you get minus 2 sin a sin b. So the problem is with the negative sign that we are getting, that is minus 2 sin a sin b. We don't want the negative sign there. So what we will do is, we will take that minus on the left. Taking that minus on the left means after we open the bracket, we will have minus of cos a plus b plus cos a minus b. So actually, to get 2 sin a sin b, you should go for cos a minus b minus cos a plus b. Use the a minus b expression first. So you can write that last formula as cos, not a plus b, but a minus b coming at the beginning, and then you will have cos of a plus b. So cos a minus b minus cos a plus b is the fourth formula, and these are some factorization formula that you should be aware about. Okay, I'm not too sure whether you call it factorization or defactorization. I've forgotten the term, but yeah, this is the set of formula that you should know. And like I've said, while you're solving the sums, the formula will be applied in the reverse manner. Okay, so you should know the derivation so that when the expression comes in front of you for simplification, you know what kind of steps you had done to derive that particular formula, and accordingly you can write whatever expression that particular formula corresponds to. So say for example you get 2 cos A cos B, then you know you have to use this formula. Let's go ahead with the next set of formulae, and the next set of formulae are going to be a variation of these formulae only. In these formulae, what I want you to do is I want you to put A plus B as C and A minus B as D. Look, if A plus B will be equal to C and A minus B will be equal to D, why don't you add them up? If you add up the two equations, you will realize that 2A will be equal to C plus D and A will be equal to C plus D divided by 2. If you subtract the two equations here, then A will get cancelled, B minus B will be 2B, and that will be C minus D. So B will be C minus D upon 2. So all I want you to do is replace A plus B with C and A minus B with D, and on doing so the right hand side will become 2 sin A cos B. In place of A and B, we will put in C plus D by 2 and C minus D by 2. Okay, so let's rewrite the first formula. Sin A plus B plus sin A minus B, we are writing it as sin C plus sin D, because I was putting A plus B as C and A minus B as D. On the right hand side, A will be replaced with C plus D by 2 and B will be replaced with C minus D by 2. So that will give us 2 sin C plus D by 2 into sin into cos C minus D by 2. That's the first formula you have to remember. Remembering these 4 formulas is going to be a little difficult, and you wouldn't be able to work out these formulae like you've been working out this set of formulae. So the set of 4 formulae that we are going to do now, of course I'll write them down first and then I'll give you a method to remember them, and with practice you will be able to remember them in a very fluent manner. So the second formula, C D 2 cos A sin B. So we have sin C minus sin D on the right. It was 2 cos A sin B. Okay, go for the third formula, cos C plus cos D. On the right it was 2 cos A cos B. So 2 cos A cos B. And the last formula was actually cos D minus cos C, because if you realize this is D and this is C, I will prefer to write the C term first, that is take a minus sign on the right only. So when you do that, here you are going to have cos C minus cos D, and when we were going for that cos C minus cos D, that is cos of A plus B minus cos of A minus B, we were getting a minus sign on the right. So this will be minus 2 sin C plus D divided by 2, because it was minus 2 sin A sin B, minus 2 sin A sin B will be replaced with C minus D upon 2. Now if you want, you can actually take that minus sign inside the sign here and write it as 2 sin C plus D by 2 into sin, the last term will be D minus C by 2. Okay, so these are 4 more formula that you are learning, and how to remember these formula. So you need to first remember the left hand side. The left hand side is sin plus sin, sin minus sin, cos plus cos, cos minus cos. Remember that sequence, the first number being C and the second number being D. On the right hand side, in your first formula, in your level 1, on the right hand side you will have sin cos, cos sin, cos cos, sin sin. Remember it as a tune, remember it as a rhythm, and slowly and steadily you will be able to memorize all these formulae like I said, with constant practice. So on the right hand side, what you have is sine cos, cos sine, cos cos, sine sine. Remember not only the tune, but remember the positioning of terms on the left, and also the terms you have here. Now here everywhere the first term is c plus d by 2, and the second term, the term in the second bracket, is c minus d by 2. Okay, so that is one thing you don't have to remember separately for all formulae. Also you have a 2 in the beginning. Just for the last formula, if you are using the regular formula, take a minus sign here. If you are not taking the minus sign here, rewrite the last bracket as not c minus d but d minus c upon 2. Okay, so again sine c plus sine d, sine plus sine, sine minus sine, cos plus cos, cos minus cos is what you have on the left. On the right, that will be a 2 common to all the expansions, c plus d by 2 and c minus d by 2 common to all the expansions as the first and second terms, and the different terms for all these expansions are sine cos, cos sine, cos cos, sine sine. Okay, with that we move on to the last set of formulae, and in this set of formula what you have is, say for example we talk of a triangle. In a triangle, a plus b plus c, okay, let's call it triangle ABC. A plus b plus c will be equal to 180 degrees. Take any one angle on the right. Say for example I am taking c on the right, so I will have a plus b is equals to 180 minus c. Take a sine on both the sides. So sine a plus b will be sine of 180 minus c, and that would give us sine a plus b. Sine of 180 minus c is sine c only. It's a concept from allied angles, and in case if you haven't learned it, there will be a separate video made on that, and you can find it in the playlist section itself. So do check out the concept of allied angles if you're not aware about it. And yeah, like I said, sine of 180 minus c, if you know allied angles, this will be sine c. In a similar way, if instead of c I will take b on the right and then take a sine, I will have sine a plus c equal to sine b, or you can even say that sine of b plus c will be equal to sine a. Basically, sine of the sum of any two angles will be equal to sine of the third angle. What if instead of sine, we would take a cos here? So we would have had cos a plus b equal to cos of 180 minus c, but cos of 180 minus c is minus cos c. Again, the concept of allied angles. If you don't know it, like I said, check out the playlist section. You can find the link in the description box below. Get thorough with the concept of allied angles. It's an important thing in trigonometry. If I take cos of b plus c, it's the same thing. Okay, again, for b plus c, a will go on the right. When you take a cos there, you will get this as cos of 180 minus a, which is minus cos a. So cos b plus c will be minus cos a. And the last one, instead of taking a or c on the right, what if you take b on the right? Cos of a plus c will then be equal to minus of cos b. In a similar way, a plus b plus c is 180, right? What if I deal in half angles? So a by 2 plus b by 2 plus c by 2, dividing both the sides by 2, we will have 180 by 2, which is 90 degree. So take that c by 2 on the right, and we have a by 2 plus b by 2 is 90 minus c by 2, and take a sine on both the sides. So you have sine a by 2 plus b by 2 equal to sine of 90 minus c by 2. Sine of 90 minus theta is cos theta. So you can write that sine of 90 minus c by 2 as cos c by 2. In a similar way, you can say that sine of a by 2 plus c by 2, that will be cos of b by 2. If these are half angles, sine becomes cos. And similarly, sine of a by 2, sine of, this time we will take a on the right. So b by 2 minus b by 2 plus c by 2, that will be sine of a by, cos of a by 2, sorry. And now, in this formula itself, instead of taking a sine on both the sides, what if we take a cos on both the sides? So on the left, it will be cos of a by 2 plus b by 2. On the right, it is cos of 90 minus c by 2. But again, cos of 90 minus theta is sin theta only. So on the right hand side we will have sine c by 2. So whether it is sine or cos, it does not, whether it is sine or cos, it does not make a difference. Both of them will get converted to the other one without the negative sign getting introduced, as long as you are dealing with half angles. So with half angles, sine of two of them will be cos of the third. Okay. In a similar way, cos of, if I say a by 2 plus c by 2, this will be sine of b by 2. Cos getting converted to sine because these are half angles. And similarly, cos of b by 2 plus c by 2, that will be sine of a by 2. Okay. So yet another important set of formulae in trigonometry that you should remember.